All right, sixth graders, lesson 54 here. Looking at factors and reducing them. So we'll copy the example you see there. Notice it's the numbers are written in order from least to greatest. So 2, 2, 3, 5, and 2, 2, and 3. What we can do here when we have factors like this over each other is we say they cancel each other out. Because we know that 2 over 2 equals 1, and 1 times anything will always equal whatever number we multiply it by. So they cancel each other out. So here's another 2 and a 2, and that makes 1 and 1. The 3 cancels out the 3, and that makes 1 and a 1. So now if we do 1 times 1 times 1 times 5, that will be 5. And 1 times 1 times 1, that will be 1, and 5 over 1 equals 5. So that would be the answer there. All right, in example 1, we see 2 times 2 times 2 times 5 over 2 times 2 times 3 times 5. We can cancel out. That 2 and 2 make it a 1 and a 1. That 2 make it a 1 and a 1. The 5 and the 5 make it a 1 and a 1. Now we can do 1 times 1 times 2 times 1, that equal 2, and 1 times 1 times 3 times 1, that will equal 3. So here our answer would be 2/3. So that's how we reduce fractions when we see all those factors listed above and below the division bar. So remember that that is a division bar, but we're able to cancel some of those out. All right, in example 2 here, they ask the question, how many halves are in 3/4? When we see a question like that, what we need to really remember is that these two numbers, 3/4 and 1/2, are going to switch. So that's like saying 3/4 over 1/2. So we're going to have to rewrite that as 3/4 divided by 1/2. So in these two instances you see here, the second number actually comes first, and the first number will go on the bottom, or it will become the second one. So we flop those around when we see this problem. Okay, in this type of problem we're asking how many, so we say 3/4 divided by 1/2, we're saying how many halves this shape here are in this shape here. Okay, well, let's see how many of them are in there, what we can do there. We can say that this guy, I could fit one of them over here. Alright, so I've redrawn another half here in blue. So what I'm asking is how many of these blue objects are there in this green one? This object, even though we call it a half, I say there's how many halves are there here? I would say, well, there's one. There's 1/2 right here. And then how much more of this half? I've still got to finish filling up this part right here. Well, how am I going to fill that part up? Well, I would fill that part up. So now if we pull this object down out of here, we again put it back over here, we say I have one of these blue pieces, and this red piece equals half of the blue. So I would say it's going to take one whole blue piece and half of the blue piece, which is red there. So my total answer is 1.5. I'm going to need 1.5 of these to fill up that 3/4 over there. So that's what we're asking up here. That's how we can visually show it. Mathematically, we can do it by doing 3/4, and we've learned we will multiply by the reciprocal. So this will be 2 over 1. 3 times 2 will be 6. 4 times 1 was 4. And that's 1.5. We've got the same answer there. So visually, that's how we would be using those pieces there in example 2. All right, example 3. We have the question, how many 3/4 are in half? And again, we've got to flip-flop these two. So we would be saying 1/2 divided by 3/4 equals. So we're asking how many 3/4 are in a half. All right, let's draw that here. So I'll draw 3/4 here, and I'm going to divide it into quarters. And over here then, I will draw my half. So what I'm asking now is how many of these fit into here? Well, you might say, well, this is way too big to fit into here. You are correct. Now, the question I want to ask you is how many pieces do you see over here? And you would say, well, I see 3 pieces there, and I'd say you're correct. 1, 2, 3 pieces. So if I could separate all of these pieces, how many of these pieces could I fit into this over here? And you would correctly tell me that, well, Mr. Vandermeer, I could fit 2 of them over there. I could fit that first blue piece, piece number 1, and I could fit the second blue piece, that number 2. So let's take these two numbers. I can fit 2 out of the 3 pieces into the half, or 2/3. So I can fit 2/3 of this, 2 out of the 3 pieces, into my half. That's how we visually show it. If we mathematically want to show, we would say again 1/2 divided by 3/4, and we have to rewrite that half and change it to multiplication. And this, we take the reciprocal, so we'll have 4 over 3. 1 times 4 is 4, 2 times 3 is 6. We reduce that, and we see we have the same number, 2/3. So we can do it that way as well. This will take a little bit of getting used to. The key part here is remembering to reverse the fractions before you do the math, and then changing this problem into a multiplication problem. So you can figure it out probably easily mathematically, but we want to show the picture to show what you are actually doing to figure these out. You can begin on your lesson practice.